Today's discussion is on probability of finding X successes in N trials. Problem reads 35% of the consumers prefer to purchase electronics online. You randomly select 8 consumers. Find the probability that the number of consumers who prefer to purchase electronics online in A is exactly 5. Well, the probability of X successes in N trials is given by the probability formula. Combination number of combinations of N sample of N with X successes times the probability raised to the X power times the complement of the probability raised to the N minus X power. So let's answer part A. The probability of 5 successes out of a sample of 8. So it's the number of combinations of a sample of 8 with 5 successes is equal to the probability of success is 0.35. Raise that to the 5th power. The probability of not having success is the complement, or 0.65 raised to the n minus x power, which is 3. Plugging in, performing the calculations, and I've rounded to 4 decimal places. So 56 times 0.0053 times 0.2746. If we multiply it out, saving each step, in other words, calculating this first, calculating this, and only going out 4 decimal places, I'm getting a final answer of 0.0815. If I do a direct calculation with the calculator, put all of this into the calculator, then hit equals, out to 4 decimal places, I'm getting 0.0808. Now, we're asked to round to 3 decimal places. Notice that there's a discrepancy. So if you're rounding at several steps to get to the final answer, which is rounded, you're going to be off in calculating the answer. It's best to do it all in one step and then round it off to 3 decimal places. That would be fine. If you can't do it that way, then I'm going to suggest carrying your saved calculations out to at least 6 digits, and that hopefully you're going to get an answer that's accurate out to 3 decimal places. Part B says we want to calculate the probability of more than 5 successes. Well, probability of X being more than 5 successes is the probability of 6 successes plus the probability of 7 successes plus the probability of 8 successes. So it's the number of combinations of 8 objects with 6 successes times 0.35 raised to the 6th power times 0.65 raised to the 2nd power. Add to that the number of combinations of out of a sample of 8 with 7 successes, 0.35 to the 7th times 0.65 to the 1st. Add to that result the number of combinations of 8 from a sample of 8 successes, 0.35 to the 8th times 0.65 to the 0. Now I've done some simplification here. I haven't quite followed what I said above. So this turns out to be 28. 0.35 to the 6th. Well, I take that back. I actually did it as one simple calculation. This times this times this out to 4 decimal places would be 0.0217. Likewise, doing this all at once out to 4 decimal places is 0.0033. This would be 0.002. If I add these 3 values up, I'm getting an answer of 0.0252. Rounded to 3 decimal places, that would be 0.025. Now, the last part, part C, says calculate the probability of at most 5. Well, most 5 says the probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3 plus the probability of 4. That's one way of doing it, but I think it's a little shorter if we want the probability of X being less than or equal to 5, to subtract from 1, which is a maximum probability of 1, minus answer B, where the probability is x greater than 5. So if we take from 1 0.0252, we're coming up with the answer of 0.9748. So again, there are two ways of doing this problem, but I think it was a little safer, not safer, but shorter, to calculate these three first and then take that from a maximum probability of 1 rather than doing more probability calculations.